So today we're going to start another type of bonding. So last week we were doing ionic bonding where the electrons were transferred. One had extras, the other one also needed them, and it just worked out. One of them took them from the other. That creates charge, and we know that opposites attract. But sometimes you have two atoms where they both need electrons. One of them doesn't have extra and they don't want to give them up. So, or both are kind of in the middle. They don't want to lose or gain. So what happens on here is what you would do if you didn't have enough money for your own pizza. So you want pizza, your friend has also wants pizza, but both of you don't have enough money. So let's just say our favorite number here is $8. And maybe you have $5 and your friend has $3. You put it together and you both have enough money to buy it. So what we're going to do then is we would put it where you put things that you share. So we'd put it in the middle. And so then you could divide that in half and both of you could pull from it. So you both would have some pizza. You both have what you want. It's not as great as having your own, but some's better than nothing. And the same thing happens between atoms. So they share electrons in order to get their favorite number, which is usually 8. So let's think about this with ions. Let's do something simple, hydrogen. So for hydrogen, each hydrogen would have 1. Now, usually things want 8, but the exception is if it's hydrogen or helium, anything in that first row, they just want to have 2. So instead of having 1 electron of their own, they're both going to take that electron and they're going to put it in the middle. Now, we like to show this together as a bond. So when you connect two things with a dashed line in here, that is called a covalent bond. So that means when I count this, for both of these electrons in the middle here, they can both count it as 2. So the goal again is to have 8, except for if you're hydrogen. Now helium's a noble gas, so it doesn't really like to bond. So usually we just worry about hydrogen. Anytime you're going to use hydrogen, all you're going to do is attach it with an H to something like that, and that will be exactly what it needs. It'll have that second electron to have a full energy level in here. Okay, so there's different types of bonds. A regular bond is called a single bond. So anytime I connect anything with a dash, that's a single bond, and we said that's going to count as 2 electrons in there. So when I do that, I just write the 2 symbols and put a little line between it. But sometimes you need to share even more. So since that's single, twice as many lines would be a double bond. And that's going to be 4 electrons. So that's going to look like an equal sign. And then finally, we'll also have a triple bond, which would be 6. So every bond is 2, so double that to 4 and triple that to 6. So it looks like an equal sign with an extra line on there. We'll talk about that in a minute when you'd want to do that. Sorry, my voice is still so awful. So what you need to do is what we've been working with all week. You need to count up the number of valence electrons. So hopefully on your periodic table by now you've written the 1 through 8 columns in there. And again, we don't use the ones in the middle. They're special. If you go on to take more chemistry, learn about more. But for now, especially since we're short on time, we're going to skip that. And we're going to start out attaching the side atoms to the center atom using single bonds. So again, we just want to connect things like that between them. If there's only one of something, it's the center atom. So for example, if I had CH4, there's only one C. So I'd want it in the middle. A good thing to know too is that hydrogen can never be in the middle because that would be more than one bond. Many times it's the first element in the formula, but not always. Like water is H2O. but usually the first element is the center element. For any element besides hydrogen, so hydrogen is special, there's even bumper stickers that say that, they want to start adding them. So what you're going to try first is just add 6 more electrons to it. Hydrogen only wants 2, so you're not going to do that. So for example, if instead of CH4, I had CH3 with iodine instead on there, so that means then I'd put my 3 H's on the C, and then over here I would have iodine. So the H's on here already have their electrons. They only want 2, and they have that. So if I add this up, I would have 4 for carbon, I would have 3 for each hydrogen, and then I would have 7 for iodine. So I have 14 to work with. So 2, 4, 6, 8. I've used 8, but I need to use 14. Now each of these H's already have 2. The carbon has 8. So who wants the electrons? Well, that's iodine. So I'm going to add 6 more over here. And that is going to give us a total of 14, which is what we want. So your goal here is to have everything connected. Everything besides hydrogen should have 8. And hydrogen, again, is only going to have a dash. So I never want to see you do this, putting dots on the hydrogen. That won't ever happen. It should always just look like this, H with a little dot. Okay, so if you haven't used all of your electrons yet, and everything has 8 on there, you're finished. So that's the easier ones than that everything's good. Then you don't have to do anything special. But if there's a problem, the problems can either be you ran out of electrons, or you have some that you're supposed to be using and you filled everything up and there's no room on there. Okay, so if you have on here, on this one on there, if you have extra electrons in there, meaning that when you did that you placed less than the total, that means the center atom does not have 8 electrons yet. So that means you're going to have to add some more to fill it up. So what we're going to add to these are lone pairs. So lone pair means it's not attached to an element, it's just sitting on the symbol. So it's kind of hogging them. So like we said, if you pay more money for pizza than somebody else, you might hog more of the pizza, you won't share as much. You're going to share the minimum that you need to get what you want, basically, on that. So for an example on here, let's say I had water. So I know water is H2O. So let's add up those electrons. 2 times 1 plus 6 more, you have 8. So there's only one O, so that's going to go in the middle. H doesn't want anymore, it's full. So I've only used 4 electrons. I have 4 left. So what I'm going to do here is put 1 pair here and 1 pair there, and those are called lone pairs. Again, when I'm talking about the lone pairs here, I'm talking about these because they're not attached to anything. Oxygen wants the electrons more than hydrogen, so it's going to hog the ones it has and only share enough to get hydrogen what it needs and be able to share. So again, something would be more likely to share with you if it benefits both of you on that, so that's why we're going to see that happen. Okay, the opposite thing that can happen on there, if some atoms don't have 8 and you haven't used all of your electrons yet, you're going to have to share more. Okay, so again, if you only have a couple dollars, a whole bunch of people would need to chip in to get pizza, whatever you're doing. So what you're going to need to do is make double or triple bonds. So try the double bond first. If that still doesn't work, you may need to make another double bond in the other direction, so like having 2 double bonds, or you may need to switch to a triple bond. All right, so I'm going to show you one, HCN. So let's add up its electrons. H is 1, C is 4, and N is 5, so I have 10. So here, everything only has 1. We know H can't be in the middle, so we're just going to draw this as is. Usually when they're giving them to you, they're kind of set up in the order that they are. Okay, so here's 2, that's 4. So I'm going to start putting my electrons on. 5, 6, 7, 8, 9, 10. Okay, so I used all my electrons, but then I look. H has 2, that's what it wants. N has 8, that's what it wants. But poor C in the middle only has 4. So the first thing I'm going to try and do here is I'm going to erase this pair of electrons. And when I do that, I'm going to switch this to a double bond. Now, if that gives everything 8, we're done. If not, we're going to either have to try a triple bond or putting a double bond on the other side. Now here we can't do that because our other atom here is H, and H can't double or triple bond. Unfortunately, we won't get to use the model kits this year, but you'll see that those only have one hole in them, H, because they only ever want to have 2 electrons. So what I'm going to need to do now is erase another pair, and it doesn't matter which side. Now I put that on there. I have used 10 electrons. I have on here 2 here, 4, 6, 8, 10. Okay, H has its 2 right here. Carbon has its 8 from 2 here and 6 here. And then nitrogen has 6 to itself. And then the last 2 are there. So that's how you draw this one. Okay, so let's try some more. And this is what I want you to turn in today to show that you work these out. You can either put them on the notes and take pictures, or you can just do this on a scrap piece of paper. Okay, so for HF, H is 1. Let's change the color, you can see a little better here. F is a halogen, so we're working with 8. So anytime you only have 2, you're just going to connect them with that single bond. And that counts as 2 electrons. Now we still have 6 more to go. H doesn't want it because H only has 2. So again, that first energy level, small atoms only want 2. So now I'm going to go around 5, 6, 7, 8. Now to see if I'm done, I see if hydrogen has 2, it does. Anytime it has a dash, it does. And F has 8. So that's it. That's all I have to do here. For CH4, carbon has 4. There are 4 hydrogen, each having 1, and we're going to get 8. You'll see that 8's a popular number, so there's like 24. There's a couple numbers to see a lot. Now here, there's only 1 C. We know H can never be in the middle. So I connect everything. That's 4 single bonds. I've used 8, and that's it, because again, H only wants 2. Carbon has 4 bonds at 2 apiece, so that's 8. Okay, CH3Br, so 4 plus 3 times 1 plus 7 is 14. So I'm going to put H's on 3 sides. It doesn't matter which one. Now there's something called the Vesper theory or valence shell electron pair repulsion theory. So when you're drawing these, you want to spread these out as far as possible because electrons are negative, so they repel each other. Okay, so I connected everything to C first. That took 8, but I still have 6 more to go. I know H doesn't want any more, but Br does, so I just dotted around there and put 6 more around. So I've used 14, carbon has 8, bromine has 8, and each H has what it wants, which is just 2. All right, now we're going to do H2S. So here's going to be one that doesn't work out right away. We have 2 times 1, and we have 6, so we have 8. There's only 1 sulfur, so let's put that in the middle. And single bond it to both H's. So that's 4. I have 4 left. H can't take any more, but S wants some. Okay, so this is pretty similar to water. So a lot of times when you have something in the middle that's S or O, anything in that column, you'll have that. And this would actually bend down if you build it with a model kit. You might have heard before water looks like Mickey Mouse. So to keep those electrons as far apart from possible, you might see sometimes people draw this bent, but you don't have to do that. All right, our last one, N2. So we have 5 times 2. That's 10. So our first step is connect it. So that's 2. Start dotting around. 3, 4, 5, 6, 7, 8, and then anywhere over here. So I'm just going to go here. It's 10. The N on the left is great. It has 8. The N on the right only has these 2 in the middle, plus these 2. That's only 4. So it tells the N on the left you need to share more. So get rid of these. And instead, we're going to put them in the middle. So that didn't hurt that N because there's 4 on the outside and then 4 in the middle, so that's 8. So we see if the end on the right's happy. No, it just says 6. So we're going to do that again. Let's steal a pair. And then draw it there. Both ends of 6 in the middle to themselves. So you'll see that atoms like to be symmetrical when we do this for the way we're going to build. Okay, so for today, I just want you to turn in these examples we have on here, and we'll practice this more on there. And then we'll start getting into building them in our own, using some little puzzle pieces and putting things together, some simulations. And then we'll also learn how to name these, and that will be the end of the naming and formula writing parts. And then we'll get in the reactions unit where you'll get to balance equations and see some cool demos and stuff. I wish we were doing more at school, but unfortunately we don't have that option. Okay, let me know if you have any questions. Thank you.